Hello, my name is Mario. Welcome to another Learning Go video. In today's episode, I'm going to be showing you how to deal with bulk insertion in relational databases, specifically using PostgreSQL. As usual, the link to the code will be in the description of this video, so feel free to check it out. I also have an example using MySQL as well. First of all, we have this file called data.csv. We're going to be reading this CSV. We're going to be reading each one of those lines, and we're going to be inserting the values into our database. I want to show you how you can do this using the standard library, and how you can use this or how you can do this using the concrete third-party package. And the difference is significant because when you're using the third-party package, you're actually using the implementation of the engine in the database. So we have a data, just like I show you a data CSV, nothing really out of the ordinary. What I have here is sort of I'm reusing what I showed you when I was describing the transactions in database SQL, and specifically the connection function that I have right here. What I'm going to be doing is, specifically in this case, I'm not going to be using database SQL. However, the methods that I'm going to be using are basically equivalent to using database SQL, but I want to use PGX because it's a little bit easier using the transactions. Again, what I showed you before, the transactions method in the connection package. Now, because I want to show you how long it takes, I want to show you also a way to indicate how long it took. So the simple way to do this is using the time package, that you can literally take a noun and then use since, and it will indicate how long it took since the noun was initialized to when you call since. Okay, so we have error, or rather we are going to be implementing a function called insert users that receives the connection and returns an error. If error is different than nil, we're going to return and say failed with the error that we receive. Now, before we do that, we need to actually run our Postgres. And then if you don't have any Postgres running, you can use Docker. But if you can use your own local, database, maybe you install it via Homebrew, or maybe you're using Linux or Windows or whatever. But I like using Docker because honestly, it's kind of easier to manage when you're running different versions and whatnot. So I have my pSQL that I'm going to be using for creating the user and the DB name, or rather, to create the actual table that I want to use. And again, all these instructions are in the README, so you can follow along. Now I have my users table that is empty. I just created. I'm running my Docker container that I can use. Now, if you remember when we were discussing about transactions in specifically when using Postgres, there is a method called transact tx begin tx func or similar. I can't recall exactly, but we will show you that in a while. That is going to be useful in this case because we're going to be reading the file, we're going to be reading each one of those lines and then inserting each one of those lines as via, or rather using the insert command, the SQL insert command, and we're going to see how long it takes, and we're going to be comparing that when you're using the actual concrete implementation that is using the copy command in PGX. So we have this. We're going to be reading the file. So for reading the file, we need to use the OS open. Alright, the OS package. The OS package has a function called open. We have a path package that indicates it's going to be used for joining the file that in the end we're going to be using for reading. So far we open the file, we concatenate it in a way that is equivalent for different operating systems. If there's an error, we return the error as usual, fmp rf os open, and then we wrap the error as we have been doing obviously for a while now. How can we read the actual CSV file? There is a CSV package in the standard library called encoding CSV. If you notice in the pop-up, So you read the you open the CSV using the new reader function in the CSV package. It receives a reader and it returns a CR file. Alright, CR. Oh no, it doesn't return a CR. It returns an instance of the reader type in the CSV package. The way it works with this is that you need to use the for loop for reading each one of those records. Now, the CR type has a next that indicates right here. Alright, not next. A read function that you can use for reading each one of the lines. Each one of this, every time you read this, or every time you call the read function, it will return a line, which is a slice of strings, and an error. In order to determine if you finish reading the file, you have to check if the errors is an EOF that indicates an end of file. If there is an end of file, you break because there is nothing else to read. If error is different than nil, maybe something else happened, you have to obviously return the error that happened in that case, which could be, you know, so many things. So we can say CR read, and again we wrap the error, and so far we have this error. Alright, this record variable that represents the lines or the columns for each one of the lines that we're reading from the CSV. What we have to do next is wrap this data into the Conn begin tx function that I was mentioning you before, that receives a context background and also pgxt options, and the function that is pgxtx and returns an error. So if you remember what I was describing you before, this is, in my opinion, a clean way to handle transactions when you happen to be using the pgx package. And we can copy all of this from here. I missed that CR line, so let me copy that over. Let's put it up here. So what is going on? So it's complaining about perhaps this one is 59 declaration. I know. And you know what? You know what? So you have this function, and actually this has to be run here. So we can get rid of this. We have. So what we have to do is basically move the content of the function to this one. What the heck is going on? Why is it taking so long? Okay, so there you go. It's complaining, it's found. Okay, so let's do something. When I'm having these kind of issues, what I like to do is take the easy route. Oh, it's an extra, you know, not a, what do I call this? Parentheses. Yes, parentheses. So I have it here. So I'm supposed to be returning nil. Okay, so everything is back to normal. So again, I open the file, the CSV, and reading each one of the lines. I'm determining if this is the end of the line, and if it is, I just return. I break, and if I break, is the end of the file. So I return. Now if I go back to this, an error, error F, and then I can say Conn begin x, begin tx, and error. So everything seems to be making sense. If I compile this, there's an error insert users, and this is because I missed an S right here. So I compile, it says insert users. There you go. I missed two S's. So record is declared and not used. Okay, I know why why is this failing, because we need to use this variable for actually inserting the records into the database. So if you remember, Conn has an exec function that receives a context background, and again, ideally in the perfect world you should be using an actual context that is coming from the function that is calling you, so you can, you know, handle propagation errors, propagation, cancellation, those kind of things. But in this case, we're just going to be using context background just for the sake of simplicity. So you have users, first name, last name, values, and again, placeholder 1, placeholder 2, close, and then we take record 0 because that's the, if you remember the way in the CSV how it's implemented, there are two columns that are represented in the slice as the 0 and the 1 in the slice. So 0, position 0 will be the first column, position 1 will be the second column. So if you also remember, the way exec works is that it returns a command tag that indicates the ID and some other information that we don't need for this specific case, and the error. So we're going to be assigning that to an empty value. If there is an error during the insert, we return an fempty error f con exec. Now all of this is just to show you how you can determine why doing this is not efficient and why you shouldn't be doing this in the first place. So everything is fine, there are no records. If I decide to run this, what is going to happen is that it's going to take 77 milliseconds, and as expected, well, I have all my records in the database. I do a count star, and there are 50 records as expected. And you can argue with me that, oh, okay, 78 milliseconds is not that much. But let me clean this up before we continue and show you the actual example using the PGX implementation and actually using the copy command. So give me a few. So what is a better way to do what we did before using the copy command and therefore the copy method in the connection type in the PGX package? So what I'm going to show you next, I'm going to go into the PGX folder. I have what we did before. I'm going to be refactoring this and showing you how what we did before can be useful for implementing what we should be doing. So insert users stays the same. One important thing is that the con type in PGX defines this function called CopyFrom, and CopyFrom defines a few different arguments that we're going to be using, and it's really simple. Okay, so you have, let me, for the sake of, you know, because I don't forget, I'm going to copy here the API. Ooh, what the heck is going on? Okay, there you go. Ah, come on. So I have it here just for showing you that the CopyFrom method in the con package receives a context, a table name, an identifier, column names, and receives a type that implements the CopyFromSource type. Again, let me jump into the implementation. CopyFrom, we're going to be following what the signature of that API indicates. This is a table name called users. Oh no, actually it has to be a PGX identifier. The columns will be first name and last name. So we have, what the heck? Okay, first name will be first name, or rather the first column will be first name, the last name will be the second one. And then we're going to have a hypothetical row source. And then row source is the type that we're going to be implementing for doing this. So what does raw source do? So before we do that, let me close this in a way that if error is different than nil, return fempty error f, because basically the whole interesting thing about this implementation is that we're going to be implementing the row source type. All right, so what is going on here? What is this complaining? So operand, oh, you know, I forgot to close the slice. So that's it. So see, everything seems to be okay. So what does the copy from source type implement? So the copy from source type in the PGX package defines three methods: next, values, and error. Now, if you remember, I'm going to be and then just for the sake of keeping this simple, I'm going to be copying the implementation, and then I'm going to be implementing a type that I define here that doesn't exist yet, called rowSrc. So I can define a type called rowSrc, a struct, and I'm going to be copying or implementing these three functions. So we have rowSrc next that returns, let's do false, just for now, so my editor doesn't complain too much. We have values that returns the values. We have finally the error method that returns an error. So if I compile this, everything is oh, of course, because CopyFrom returns also, oh, you know what, let's do the same, count an error, because it actually, the CopyFrom indicates how many rows were inserted into our database. So I want to print that out because it's important. So I want to be fmp println. Let me move this up so you can see rows count. So everything seems to be working according to the compiler. That is, it's not actually working in real life. But I want to show you that what is important here is we're going to be taking what we did before, we're going to be refactoring that and making sure that the implementation that we had before using this begin from transaction that is right here, let me add use a comment to separate these two things, will be what we're going to be using next. Now, if you remember, there are three functions, one called next, values, and error. So what we have to have here is in a way to receive the CSV reader and then read that from the functions that are exported and that are used by the PGX Conn type via the CopyFrom method. So we have CR, so CSV reader. Then we are going to have here values, which will be an interface and a slice of an interface. We're going to have an error, and if you notice, those three fields that we're going to be defining in this type are going to be used in the methods that we have right here. So values will be returning literally values and error, nothing else. Obviously referring to the actual type. Error will be returning error, and next is actually the one doing the actual work, and this is where we're going to be taking what we implemented before and moving it up. We're going to be extracting what we had in this implementation that I have right here, highlighting it, and moving it up to the actual new type. So next is sort of like what we did before, is literally reading each one of these lines. So we're going to be doing, hey, if there is a record, or rather, if there is the end of the file, we return false because there is nothing else to read. If there is an error, what we're going to be doing is assigning the error that we have local to the type and return false. Okay. And next, we're going to be doing the values. Values will be a make of an interface, an empty interface. And we know that it's 2 because there are only 2 columns in each one of the rows. So our values 0 will be equal to record 0, and our values 1 will be equal to record 1. So with this in place, we can actually get rid of all of the things below, and that will be the implementation that we have to have for using the copy command and therefore the CopyFrom method in the Conn package. Let's go look at it again. So we have a function, or rather we have a type called rowSource that implements 3 methods: next, values, right here, and error. And these 3 methods are internally used by a function, or rather a method in the Conn type called CopyFrom, and CopyFrom receives that type that is right here to read the data that we're going to be we're supposed to be inserting into the database. So if we compile this, oh, CR is failing because I missed I was referring to the actual field in the type. So another error that I have here, so this will be the reader. Did I call it the reader, or what did I call it? I forgot. See, I actually call it CR, so I need to rename this to CR. And with that, everything seems to be compiled. Let's run again. We don't have any users in our database, in our table. If I go and do run a main, it will take 7 milliseconds. Let's run what did happen. So I have something went wrong. So it says something. It's most likely was in the insert, or rather in the next. So, if of course, I'm returning false where I should be returning actually true, because there was no error. So if I run this again, now I have, and it's taking me 7 milliseconds. I run this, instead of running a select star, let me do a select count, and now I have 50 rows. Now remember what we had before with 47 milliseconds to 7 milliseconds. Now think about this in terms of millions of records, right? You can use insert for sure, and that is going to work. But if you use the command that is meant to be used for loading data, for doing bulk insertions into PostgreSQL specifically, in this case, it will be significantly faster. Now, I highly encourage you to take a look at the method that I just described you, and it's really, I mean, in my opinion, it's really easy to use, because it just defines sort of like what you will be doing if you're using packages like the IO. It's super similar, and I think the interface is the user experience, and the API that they define in the PGX package is pretty straightforward. And again, any questions or any comments about bulk insertion using PostgreSQL, please let me know in the comments section below. I will talk to you next time, and please take care and stay safe. See you.